You are tuned to Iri-e-learning, and I am your host, Teacher. In this lesson on mixtures and separation, we will examine the separation technique using the separating funnel. Check the description box for links to all the videos related to this unit.
By the end of this lesson, we should be able to determine the properties of the components of mixtures that are separated using the separating funnel and explain how immiscible liquids are separated using the separating funnel. Let us do a quick recap. Remember that the components of a mixture are separated based on their physical properties, which include particle size, crystalline shape, boiling point, solubility, magnetism, sublimation, density, and other properties not noted on this particular list. During the introduction, we mentioned the term immiscible liquids. So we'll start by defining that term. A simple definition states that immiscible liquids are liquids that do not mix. Here we have the most common example of immiscible liquids, oil and water. Notice what happens as the oil is added to the water. The two liquids do not mix to form a single homogeneous layer. That is, one liquid does not dissolve in the other. As a result, they exist in two separate layers. Let us take a look at examples of immiscible liquids with two layers or phases. These immiscible mixtures have two layers because they consist of two liquids that do not mix. And we are starting off with our most popular, oil and water. If you notice, the oil is on the top and the water is the bottom layer. We also have oil and honey. Here, once again, the oil is the top layer and the honey is the bottom layer. Next is an example of an immiscible mixture with three layers. That is, it has three liquids that do not mix. Starting from the top layer, we have the olive oil. In the middle, it's castor oil. And at the bottom layer here, we have honey. What are the properties that cause immiscibility of liquids? One, the insolubility of one liquid in the other. And two, the difference in the densities of the liquids that causes the liquids to separate into layers. It's also important to note that these two properties, insolubility and the difference in the densities of the liquids, will allow for the separation of the two or more liquids in an immiscible mixture. Now, we just learned that liquids that do not mix are called immiscible liquids. On the other hand, liquids that mix are called miscible. And of course, examples of liquids that mix include ethanol and water, syrup and water. I'm sure you can think of a few other examples. In other words, what we're saying is that liquid in liquid solutions are miscible. Separating immiscible liquids. An immiscible mixture of oil and water has been placed in the separating funnel. Notice there are two distinct layers. The less dense oil layer at the top and the more dense water layer at the bottom. Remove the stopper from the top of the separating funnel to allow the outflow of liquid when the tap is opened. Slowly open the tap of the separating funnel to release the more dense liquid layer, that is, the bottom layer, as a steady drip. When the more dense liquid layer has been drained and collected, close the tap to prevent the release of the next liquid layer. The more dense liquid layer, the water, is collected. The less dense oil layer remains in the separating funnel and can be poured out. We're at the end of our lesson, so let's do a quick lesson summary. Liquids that do not mix are immiscible. Immiscible liquids are separated using a separating funnel. Immiscible liquids are easily separated because they do not mix and their densities differ. So it's quiz time, and you have 5 seconds to answer each question after it is read aloud.
Question 1. What type of mixture is separated using a separating funnel? A. Suspension. B. Solution. C. Miscible liquids. D. Immiscible liquids. The answer is D. Immiscible liquids are separated using a separating funnel.
Question 2. Which mixture is immiscible? A. Salt and water. B. Oil and water. C. Sand and water. D. Syrup and water. The answer is oil and water. And as we know, oil and water are immiscible liquids because they do not mix. Question 3. Which apparatus is used to separate immiscible liquids? A. Filter funnel. B. Sieve. C. Separating funnel. D. Erlenmeyer flask. And the answer is C. Separating funnel. Question 4. Identify a physical property that allows for the separation of the components of an immiscible mixture. A. Density. B. Particle size. C. Crystalline structure. D. Boiling point. The answer is A. Density. Question 5. Identify the statement that is correct about separating a mixture of oil and water using a separating funnel. 1. Water is less dense than oil. 2. Oil is less dense than water. 3. The water is released from the separating funnel as the bottom layer. 4. The oil is released from the separating funnel as the bottom layer. And the options are A. 1 and 3, B. 1 and 4, C. 2 and 3, D. 2 and 4. The answer is C. 2 and 3.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.